So today we are going to talk about 2D, which is called dimensional analysis. We've been doing this already, but these are kind of more in-depth problems that we're going to look at. And so again, it's everything that we've been doing, but we're just getting into more complex problems with it, basically. So the first thing we're going to look at is currency conversions. And I'm waiting for my file to open, and then we can get going. So currency conversions, we treat like converting between systems. So when we were talking on Tuesday, we were talking about converting between the metric and the American system. And so the same idea is true in terms of choosing the conversion factor that is appropriate based upon what your starting amount is. So I am sitting here and continuing to talk because my file will not open. So we will just keep talking. So currency conversion can be a little bit confusing in terms of choosing which conversion factor to use. But like I said, think about what you're starting with and what you're trying to get to. And that will help you to choose the right one. So. Okay, so I cannot get this page to open, but let me share the PDF so we can talk about that. So these are current as of July 2022, and it was one of the first time that the euro and the dollar were equal. They aren't anymore. But on the date in July that I pulled these numbers and updated this notebook page, they were equal, which is crazy because that never happens. And of course, now they're not anymore. But we're going to use these as they are. So when we look at this first column, it says dollars per foreign. What I want you to think when we have dollars per foreign, and foreign per dollar.
I bought something in Canadian money a couple months ago, and it was like 90 Canadian, and I got it for 70 American.
Yeah, so that's showing that the American dollar is stronger than the Canadian dollar, right? Because it's using less of our money to purchase something of theirs, right? And that has been a recent flip. So when I first moved to the Flathead Valley, like, when did I move there originally? I think I moved there in 2012 or 2011, 2012. I moved there in 2012. The Canadian dollar was significantly stronger than the American dollar. And so Costco was just full of Canadians. And I remember moving there, not understanding why I would see all these carts with nothing but dairy in them, and it would be milk and cheese, like their whole carts would be milk and cheese. And I'm like, why? And it's because there's a crazy tax on dairy in Canada. And so it was a lot cheaper for them to come down to the United States and purchase it there and then go back. And I guess tires as well, there was a crazy tax. But now with the American dollar being a lot stronger than the Canadian dollar, that is not something that's necessarily happening as much. And it is also affecting tourism with just inflation in general. So I'm just going to copy this table down because unfortunately, like I can't get the notebook page to open. So give me 1 second, okay? Okay, so yes, this is a very crude writing of what you have on your notebook page, but we've got dollars per foreign or foreign per dollar. So what does it mean for these two rows here? Because I've got the British pound and it's $1.18 or 85 cents or what it appears to, but dollars per foreign, what this means is US dollars. So 1 US dollar per, or excuse me, not 1 US, but US dollars per 1 foreign. So for the British pound, it says 118. That means that it's $1.18 US dollars per 1 British pound. That's how you want to interpret that that location. And the next one we got 0.85. That means 0.85 British pounds per. Remember, the per is the division sign. A US dollar. And that's how you're going to think about those conversion factors. So again, we're choosing the right conversion factor. So the first column is when you're going from foreign to US. In the second column is when we're going from US to foreign. So let me write out the rest of the values that we have in here. Okay. So how do we use this? So number one says, how many pesos can you buy with $100? And that $100 is a US amount, right? So when we think about this, we're going from foreign to US. So knowing that we're starting with a foreign currency, we want to convert it to a US currency. When we look at our columns, that means we want to choose the conversion factor from the first column, right? Because the first column is going from foreign to US. So we're going to use the conversion factor that says there are excuse me, not from foreign. We're going from US to foreign. I apologize. Not having my notebook open, like the fact that it won't open is like causing me to have anxiety right now and be flustered. So we have US money. We have $100 US and we want to buy pesos. So what that indicates is we are going from US to foreign. So when we have from US to foreign, we want that second column. So we're going to use the 20.97. So that says that we have 20.97 pesos per $1 US. So we're going to put in our $100 US over 1, and we're going to multiply it by 20.97 pesos for $1 US. So what does that, how much money do we have then? So we multiply together and this gives us 2,097 pesos. So number 2 says convert 60 British pounds to US dollars. So unless you do this one on your own, I'm going to zoom out. So in case you don't have your notebook in front of you, you can at least see the conversions. Okay, so when we're converting British pounds to US dollar, meaning we're going from foreign to US. So looking at our columns, the foreign to US is that first column. So we're going to choose the $1.18 US per 1 British pound. We're going to do 60 British pounds times a $1.18 per 1 British pound. Multiplying through, we get $70.80. Okay, so I'm going to skip number 3. We're going to look at number 4. Actually, I'm going to skip number 4 as well. Let's go to number 5 on the next page. So number 5 on the next page says, convert 350 to Canadian dollars. So we've got so CAD is the shortened version of Canadian dollars. You'll see that. And then later when we do number 1 down here, you can see that CAD, it just means Canadian dollars. So if we go back to our conversion sheet, we're looking at, we're taking US dollars and we're converting it to Canadian. So I want you to choose the conversion factor that is appropriate and send me your answer in a direct message. So again, we're doing number 5, which says to convert 350 to Canadian dollars, which means we're going from US to Canadian. So let me show you my handwritten notes. Okay. So because we're converting US dollars to Canadian, we are going to use this column here. So when we look at the Canadian, we've got 132 Canadian per US dollar. That's what this means. 100, or excuse me, not 100, $1.32 CAD per 1 US. So that's the conversion factor we want to use. So going down to our problem, we're going to do 350 US times $1.32 Canadian over 1 US. The US dollars will cancel. I try to only use the dollar symbol when I'm talking about American dollars. But again, it's Canadian dollars, right? So they're going to use the dollar symbol as well. But for us, I'm trying to be consistent. Make sure when you're choosing if you have not written this above your notes, remember, we have the first column is when we're going from foreign to US, And the second column is when we're going from US to foreign. So again, when you see, because in your homework, they're going to give you this table and it's going to say dollars per foreign and foreign per dollar. So I want you to match up that verbiage in your homework with what we have in our notes. Their conversion factors will be different based upon when they pulled them. But again, knowing which column to choose is based upon what starting currency you have and what ending currency you want. Okay. So when I multiply these together, I end up with 462 Canadian. Okay. So let's look at our next problem. So in our notebook, it says a gas station in Canada sells gasoline for $1.34 per liter. And that's a Canadian $1.34 per liter. And again, CAD is an abbreviation for Canadian dollars. What is this price in dollars per gallon? So we've got a couple of different things we need to do here. So we've got $1.34 Canadian per liter. And we want to convert it to US dollars per gallon, right?
Hey, Erin, we're not seeing your writing anywhere.
No, I know. I'm just copying it down so that when I switch back to it, we'll be able to see my writing. I was just writing that part down. If we go up to, we're going to need our conversion factors though, right? And so we want to take our US, or excuse me, our Canadian, and we're going to make US with it, right? So if we go back to my handwritten stuff, we want to look at the conversion factor that's going to give us US. So this means we're going from foreign to US. So does anybody have that conversion factor to share? Trying not to switch back and forth all the time.
Should be 1.32.
Okay, so that's foreign per dollar, which means
Right.
we're gonna have a US dollar in the denominator. So if I multiply them, then we're gonna not have the US dollar that cancel out. So
Okay.
if we write this piece out as a fraction, this is our starting conversion factor. I've got $1.34 CAD over 1 liter. And I'm going to multiply it. I'm going to give you a hint. We're going to multiply it by 2 conversion factors. So that eventually we end up with US dollars over gallons.
So, for liters, for the numerator, it'll be 0.2642 gallons.
So do we want gallons in the numerator or we want gallons in the denominator?
I guess we'd want it in the denominator so that we
Right.
can multiply across.
So we are gonna want to choose the conversion factor that has liters in the numerator and gallons in the denominator. And for money, we want US in the numerator and Canadian in the denominator.
Okay, so we have 2 separate fractions for weight, or I mean for volume and price.
Right, so we're using 2 different pieces here. We've got
Okay.
one that it's going to convert our price for us and one that's going to convert our volume for us. So our price conversion, again, we're looking at going from foreign to US. So So if I go back to my table, foreign to US is that first column, which means we're gonna have 76 cents per 1 Canadian. So we're gonna put 0.76 for 1 Canadian. And again, how do I know that's the one I want? Because it's dollars per foreign, which means the foreign is in the denominator, which is going to cancel that unit of measure out. For the second one, we have, if we're looking at our other conversion sheet, let me pull that up so I have that available to us. Oh, I guess I can go back. We want to look at the relationship between gallons and liters. So I want 1 gallon in the denominator. Therefore, I'm going to be choosing this conversion factor right here that says 1 gallon is approximately equal to 3.785 liters.
So Aaron, why gallons in the denominator? Is it because it's coherent with the US dollars
So how do you buy your gas?
by the gallon?
Right, exactly. So we're thinking about like, well, I mean, you know, it's the worst thing ever when we go to the pump these days, right? We see this money amount and it's money per gallon and we're like, oh my God, it's so high. But nonetheless, when we purchase our own gas, it's dollars per gallon, right? Which
Okay.
means thinking the word per means division. So in our fraction, we need gallons to end up in the denominator for us.
Okay.
And so that's why we're choosing the conversion factor that's going to give us that 1 gallon in the denominator.
Okay.
So moving across this, we're going to take, again, we got really lucky. All of our denominators are 1. So we're just going to end up with a 1 down here. And in the numerator, we've got 1.34 times 0.76 times 3.785. And this gives us approximately $3.85 per gallon. Which, how does that compare to gas up in the Flathead? How is that doing up there for you all? Or in Livingston? I know Brittany and Melissa, you guys are both in Livingston, right? Isn't that where you're at?
Lewistown.
Lewistown. Oh,
But yeah, we're about 385, 383.
So for some reason,
Pretty
gas
good.
is very cheap in Tennessee. So we're at, our Costco is $2.94 a gallon, which I recognize is insane. But, you know, when we first moved here back in March, it was, I think it was like $2.50 a gallon or something like that. Like it was even more ridiculously less expensive. But it's weird. I still don't understand. I mean, I do understand in terms of like transportation and like getting gas to where it needs to go, and it's expensive in the Flathead or in Lewistown because it's off the beaten path, right? Like they have to truck it there. But I still think it's dumb. It shouldn't
Well,
be.
we were at almost $5 this summer. It was like $4.95, $4.99. It was ridiculous.
Oh. Well, and I will say, so like my father-in-law, he lives in Pennsylvania and we've been up to see him a couple of times. And during the summer when we went up there, we paid like $5.50 a gallon at one point. And I was like, this is disgusting. Where my mother-in-law lives out in Seattle and it was over $6 like the whole summer. And I was like, okay, I don't need to deal with that. I'll take my cheap gas.
In California, it was $7.50.
Oh yeah, no, it's crazy. I have friends in California still, and yeah, I really felt for them. So again, looking at why did we choose the conversion factors we chose, it's thinking about what units of measure you want in your numerator, what units of measure you want in your denominator, and trying to choose those units that are going to give you ones all the way across those denominators. Okay. So we've got our next problem is kind of a big problem. So I'm going to write it out. I'm going to show you the notebook page while I write it out. And this is the light bulb example. Let me share the notebook page with you. And so it says Flathead Electric charges 15 cents per kilowatt hour of electricity. How much does it cost to keep a 100-watt bulb on for a week? Let's say you're going on vacation, you want to trick those people from thinking that you're home and therefore shouldn't break into your house because it works, right? You leave a light bulb on 24/7, nobody will break in. Anyways, how much will you save in a year if you replace the bulb with an LED bulb that provides the same amount of light for only 25 watts of power? Now, I think this is a really good example because, especially when LEDs first came out, and they're very popular now, like they've almost replaced incandescent light bulbs. There's this whole idea of like, you'll save so much money, but most people are not going to sit down and figure out how much money you're going to save over the course of a year just by replacing a light bulb. So let's do the math. Let's just see. So when it says so Flathead Electric charges, I see it says changes, but it's charges 15 cents per kilowatt hour of electricity. How much does it cost to keep a 100-watt bulb on for a week? And then what if we change to a 25-watt bulb, and what will we save in a year? Okay, so we have some terminology that we need to define here. And so first of all, when it says a 100-watt bulb, what that means is that it uses 100 watts per hour. Okay, so that's how you want to interpret that. So a 25-watt bulb would use 25 watts per hour. So let's first look at the cost for 1 week. So we've got our 100-watt bulb. And the first thing we want to do is we want to convert that from watts to kilowatts. And the reason why I say that is because Flathead Electric is saying, well, we're not charging you a price per watt, we're charging you a price per kilowatt. So kilo means 1,000, therefore 1 kilowatt is equal to 1,000 watts. And from here, we are going to, what does that equal? That equals, what do we get here? 0.1 kilowatts. Okay, so what that tells us is that that one bulb uses 0.1 kilowatts for an hour. So we're going to say 0.1 kilowatts for 1 hour times 24 hours in 1 day times 7 days in 1 week. Because we want to know how much does it cost to keep it on for a week, right? So what this is telling us is that, so we're going to do 0.1 kilowatts times 24 times 7 gives us 16.8 kilowatts per week. That's how much energy we use in 1 week to keep it on. So we're now going to take this amount and multiply it by our kilowatt hours. So we're going to take 16.8 kilowatts and we're going to multiply it by our 0.15, which gives us $2.52 per week to keep that bad boy on. Not a big deal, right? $2.52. We're not going to worry about it. But what if we go with the cheaper bulb? How does that help? So let's look at our savings. So the 25 watt bulb how much of the original wattage are we using? Like what fraction by switching to a 25 watt bulb? So from 100 watts down to 25 watts, what fraction are we now using?
1/4.
Yeah. So that means we're using 1/4 of the energy of the 100 watt bulb. So if we take that 16.8 kilowatts over 1 week and we multiply it by 1/4, we end up with 4.2 kilowatts over 1 week, right? So what can we do to come up with our savings over the course of a whole year? We know how much energy and the cost for 1 week for the 100 watt bulb, and we know how much energy for the 25 watt bulb. How can we come up with an amount for the whole year that would tell us our savings?
Multiply each amount per week by 300, or not 357, or how many weeks are in a year?
So there's 52 weeks in a year.
And subtract.
And we would subtract. So what do we still need for the 25 watt bulb? We have the energy amount, but do we have the price?
No. So we'd have to multiply the kilowatts by your price per week.
Right. So we need to take our 4.2. And we're going to multiply it by 0.15. So 4.2 times 0.15 gives us 63 cents. So do I care about how much individually it's going to cost for each of them over the course of the whole year? Or do I just care about the savings over the course of the year?
I thought you cared about both because you had to subtract.
I do have to subtract, but I can subtract from the very beginning. Meaning if I've got $2.52 per week for the original one and $63 or 63 cents per week for the second one, I can do 2.52 minus 63, which gives us $1.89 in savings per week. So if we take $1.89, we multiply it by 52, that tells us that in a year, by switching out the light bulb, we're going to save $98.28. So in the short term, that doesn't seem like a great, you're like, oh, great. Well, you're saving, 63, or it goes down to 63 cents or $1.89. But when you add that up over the course of the whole year, it's almost $100, right? That's easily 3 gallons of gas. I'm kidding. But it does add up over the course. So that's why switching to those lower watt bulbs can be helpful. Okay. Let's look at medication dosage, number 3. So let me share that notebook page with you again. So a child weighing 15 kilograms has a bacterial ear infection. A physician orders treatment with amoxicillin at a dose based on 30 milligrams per kilogram of body weight per day, divided into doses every 12 hours. How much amoxicillin should the child be prescribed every 12 hours? Oh, I'm so excited. Guess what? I got it to open. So now there's no more switching back and forth. Okay. So lots of information here. So we need to pick out what is important. So if we look at what is the dosage?
It's 30 milligrams per kilogram.
Milligrams per kilogram. And then we're going to do per day, or not per day, put, yeah, per day. So we need to look at how much they should take every 12 hours. So how many hours are there in a day?
24.
Right. So then every 12 hours, they only need to take 15 milligrams per kilogram per 12 hours. Now, is that all we're going to tell them? Or are we going to say, oh, wait, no, you actually have an amount of drug you need to take?
There's an actual amount.
Right. So we know the child weighs 12 or 15 kilograms. So thinking about wanting our conversion factors to cancel, we know that we have kilograms in the numerator. So we're going to write this as 15 milligrams over 1 kilogram per 12 hours. Now, why is this helpful? Why am I writing a double conversion factor in the denominator? And it's because our kilograms will cancel. And we are going to be given 15 times 15, which gives us 225 milligrams per 12 hours. Now, the second part trips students up a lot. So I want to focus on this. It says, if the medicine is to be taken in a liquid suspension with a concentration of 25 milligrams per milliliter. So again, this is 25 milligrams per 1 milliliter. How much
Hey,
did the
Oh, sorry. What is a liquid suspension?
when they say liquid suspension, it just means it's a liquid. So it's what they're trying to say is that the drug is in liquid form. That's what we refer to as a liquid suspension. So
Okay.
like you think of cough syrup for kids, like
Right.
that's a liquid suspension because, you know, technically usually cough syrup has codeine in it. It's got Tylenol in it,
Right.
all of those things. And so they are suspended in liquid form.
Okay. Thank you. I wasn't
Yeah.
sure what it was.
So we want to take this dosage, 225 milligrams over 12 hours. And we want to multiply by a conversion factor. So we are given the conversion factor, but we have to make a decision on how we put it in. And by what I mean is how we put it in. Are we going to say 25 milligrams over 1 milliliter, or 1 milliliter for 25 milligrams. Because it's a fraction and it's an equivalent, this is called a unit conversion, right? So we're saying that those two are equivalent to each other. So we can write it either way as long as we're being consistent. Now, when trying to answer this, remember, what is the unit of measure we want to cancel? We want to cancel milligrams because we want to know how much liquid the child needs to take, which that liquid is in milliliters. And therefore, we're actually going to have to flip this conversion factor and put it in as 1 milliliter per 25 milligrams. So multiplying through, I end up with 225. So our milligrams cancel, and we end up with 225 milliliters over 25. Right, if we did 12 times 25. So we're going to need to divide that 225 by 25, which gives us 9 milliliters over 12 hours. And yes, I know technically speaking, 9 and 12, that fraction, we can reduce that, but we don't care about reducing it right now because of the fact that we're saying how much does the child take every 12 hours. And so again, how did I get the 9, 225 divided by 25 is where I get the 9. So that's how I come up with 9 milliliters over 12 hours. And so they're gonna, get a little shot glass and you measure out the amount, and that's what the kid takes. Okay, we have one more. It's kind of an involved one. I think we talked about trying to get it into 2E. And you know what? We're going to skip number 4 because it's a really involved example, and it's a good example, but you're not really going to do anything that complicated on your homework. And so I'd rather us start looking at 2E than taking up our time to do number 4. If you want to do it on your own, you're more than welcome to. But let's switch to 2E. So 2E is going to feel like a huge change because we're now looking at percentages, but it does kind of all come together why we've switched to percentages once we get to 2F. And so the world of unit conversion and the world of percentages kind of come together in 2F. So focusing on 2E. So we're looking at percent, which means parts per 100, and changing a percent to a fraction. To change a percent to a fraction, you drop the percent sign and put the number over 100. To change a fraction to a percent, we divide the numerator by the denominator, change the fraction to a decimal, and then you move the decimal point 2 places to the right and add a percent symbol. And then we have more instructions on changing a percent to a decimal and a decimal to percent. And I don't want to get too deep into those before we start practicing because it can get confusing if we do too many definitions without actually getting into the problems. So when we think about percent, again, percent means parts per 100, right? So when we think per 100, it's going to be out of 100, okay? And then I also want you to think of it as being the part is to the whole. And so the part is to the whole as your percent amount is to 100. So what does that look like in practice? Well, number 1 says 15 is what percent of 50? So if we diagram this sentence, it's saying we don't know the percent amount, but we know that 15 is being related to 50. And so 15 is a percent of 50. So 15 would be the part, with 50 being the whole. So we would say 15 is to 50 as X is to 100, because the X represents the percent amount that we're trying to solve for. So when we set these up, we're gonna use cross multiplication. So I'm gonna do 100 times 15 plus 50 times x, or not plus, equals 50 times x. So 15 times 100 becomes 1500. Divide by 50. And x is equal to 30%.
Aaron, why didn't you just divide 15 by 30 or 15 by 50 and multiply it by 100?
And
Why
that
did
is
you
a,
set it up like
that's
that?
a completely valid alternative. So the or here is you could take 15 over 50, dividing it, we get 0.3, and 0.3 times 100 gives us 30%. So the reason I did it as a ratio or a
Mhm.
proportion is to give us the idea of how to set it up every time when we're trying to figure out what piece we're missing.
Okay, okay.
So if I look at number 2, it says 162.5% of what number is 286. So our percent always goes over 100. Now the question is, does the 286 go in the numerator or does it go in the denominator? Well, we know that 286 is 162% of something. And so it's related to the 162.5. So it's going to go in the numerator in the same position as that 162.5%. And then our variable will go in the denominator. So cross multiplying, we're going to have 162.5x equals, I really need to redo this so we have more room to write this stuff out. And then we have 286 times 100. So simplifying, we'll have 162.5 equals 28,600, and then dividing, we end up with 176. So again, going back to the original question, what were they even asking? Well, they're saying that 286 is 162.5% of 176. So 176 would be that starting value that we find the percent of. Again, the reason that 286 is bigger than 176 is because we were looking for an amount that's more than 100%, and therefore it is larger. So Laura knows that 20% of her class is absent. If the class has 45 students, how many students are absent? So 20% of her students. So 20% out of 100, and we're trying to find what amount of her students that is. So this is one setup, or we can say 20% of her students and also solve it that way. Again, 20% is 0.2. And so some of you may have seen this as just saying, well, previously I've learned that you just do 0.2 times 45. Both of these methods are going to get us there. And it's going to come up with 9 students that we're missing.
Aaron, I have another question. Sorry. So when we're doing like the cross multiplying, is it the same as fractions where you can also simplify across?
Not over an equal sign.
Okay.
You can only simplify when there's multiplication happening in between them.
Okay.
Like it's what I mean, multiplication. I know that we are cross multiplying, so you're like, well, there is multiplication happening. But instead of an equal sign there, you would have a multiplication symbol, and then you can simplify. But when we have an equal sign using cross product, you cannot simplify that.
Okay. Thank you.
So I want you guys to try number 4. It says Mike answered 90% of the questions on his math test correctly. If Mike had 27 correct answers, how many questions were on the test? Hey, Kaylee, will you mute yourself?
Oh yeah, sorry.
It's okay. So Mike answered 90% of the questions correctly. And so the correct answers were 27, so that represents the 90%. The X represents the amount that were total on the exam. So cross multiplying, dividing, we get X equals 30. Okay, so we're going to switch gears and talk about absolute and relative change. So if we look at our box here, absolute change describes the actual increase or decrease from a reference value to a new value. And when we mean reference value, I just want you to think starting value. Like, what did you start with? And then we have the new value, which would be like, what did you end with? And then you have the relative change, which is where you compare that change in the amount to the original amount. So again, when we think of the relative change, it's the new amount minus the old amount compared to the old amount, okay? So again, how did I get the 30? If we cross multiply, 90 times X equals 100 times 27. We divide by 90. And X equals 30. Okay, so number 5 says, during a 6-month period, Xerox stock doubled in price from $7 to $14. What were the absolute and relative changes in the stock price? So we start with the absolute. The absolute change is just the change in the price. So it started at 7 and it ended at 14. So we're going to just do 14 minus 7, which gives us an absolute change of $7. But understanding that the impact of that change, we need to find the percent change, which is the relative change. So the relative change is that change in the amount as compared to the original amount. So we're going to do the new amount minus the old amount divided by the old amount. And then we multiply by 100 so that we can convert it to a percent. So if we simplify this, 14 minus 7 is 7. And 7 divided by 7 is 1. So 1 times 100 gives us 100% increase in price. So technically speaking, people will also refer to this as doubling, like the price doubled. But the problem with calling it doubling is that then people try to say, oh, well, that's a 200% increase. And no, doubling means 100% increase because it increased by the same amount that it started with. Okay. So that terminology can get confusing if it gets intermixed. So number 6 says estimated world population was 2.7 billion in 1953 and 7.1 billion in 2013. Describe the absolute and relative change in world populations over this 60-year period. FYI, you don't need to use the actual 60-year portion. We're just saying, what did it start with? What did it end with? So remember, the relative change is end minus start. And then the absolute change, no, excuse me, I'm writing those out backwards. This is the absolute, and this is the relative, is the end minus the start divided by the starting amount times 100. Oh. Okay, so the absolute change, we would take the ending amount, which is 7.1 billion, minus the starting amount, which is 2.7 billion. And yes, I know I'm not actually converting these to billions, meaning writing out all the zeros, but they're both measurements in billions, so we're just going to subtract them. And this is going to give us a difference of 4.4 billion. To find the relative change, I'm going to take the ending amount, 7.1, minus the starting amount, 2.7, and divide that by the starting amount of 2.7. And yes, I know we don't have the word billion in there, but they're all billions, so we don't have to really worry about it, right? If you wanted to write them all out, once you end up subtracting them and dividing, you're going to end up with a 10 to the 9th in the numerator and a 10 to the 9th in the denominator, and they just cancel themselves out. So again, we end up multiplying this amount by 100. So if we reduce, we're gonna have 4.4 over 2.7. And 4.4 divided by 2.7 is 1.629. And then it's 629, repeating. And don't forget, we need to multiply this by 100, which gives us 162.9629%. And if we round to the nearest tenth, we're gonna say 162, or excuse me, 163.0% approximately. So if you gave me 162.96, great. You went more accurate than I did. With these problems, it's going to tell you to round to a certain number of decimal places. They mean convert it to a percent first, then round your answer. Okay. So. And then number 7 says average pay for full-time wage earners varies from state to state. Data from 2009, which was released in 2013, show that New York ranked first in average pay at about $60,300 person. $60,300 per person. And South Dakota ranked last in $32,800 per person. Compare average pay in South Dakota to that in New York in both absolute and relative terms. So to give you a hint, treat South Dakota as the starting amount. Because we're comparing the New York to the South Dakota pay, and therefore the South Dakota pays are going to be our reference value, and therefore it's going to be our starting value. So again, I want to know the absolute change and then the relative change. And if you want, after you send me your answers, and you get an okay from me, you're fair to leave because we're like right up at the edge of class. So we only have about 2 minutes left. So it's okay if you have to go.
I just have one quick question. When are you gonna grade our grade book project?
Those will probably, I'll work on those tomorrow as well.
Okay, thank you. See ya.
Bye. So if we look at the absolute change. So the absolute change is going to be 60,300, because that's the ending amount, right? I mean, again, we're going back to these formulas up here. Okay, so 60,300 minus our starting amount, which is 32,800, which when we subtract those, we get a relative change of 27,500. So on average, people in New York earned $27,500 more a year than people in South Dakota. So if we look at the relative change, again, the relative is the ending amount minus your starting amount. So 60,300 minus 32,800 divided by your starting amount, 32,800. And then times 100. We already know the numerator reduces to 27,500. So we're going to take that amount and divide it by 32,800. So taking 27,500 and dividing it by 32,800, we get 0.83841, blah, blah, blah. So multiplying it by 100, we end up with 83.84%. So it's an 83.84% increase on the South Dakota pay. Or another way to look at it is that pay in New York is 183.84% of South Dakota pay. Because they're earning what South Dakota is earning plus an additional 83.84%. All right. That is all I'm going to cover for today. We'll pick up the rest of 2E on Tuesday and cover 2F, and then whatever we don't cover from 2F, we'll cover on Wednesday. Okay. All right. I hope everybody has a good weekend, and I will see you next week. Bye, everyone.